Hey everyone, in this video I'm teaching you GNU Octave from absolute zero. Octave is a free open source alternative to MATLAB used for math, matrices, engineering, and scientific computing. There's no prior coding needed. So if you click in Google Octave Online Compiler, you can use these, or you can go to the website octave.org and you can download this Microsoft Windows if you're using Windows or Mac OS. So once you finish downloading the Windows 64 recommended version, you should be getting this one, which is should open up like this. And and each of these have its own purpose. The ones that you see over here, file browser. So this file browser is the folder that you're working in, right? And you'll see this when you save scripts. And this is the command window where you can type commands. It's the workspaces, right? It lists all the variables that you create so you can track your data. And here's where you can use variability. This is for scripts, right? This is for scripts, and this is command window. So let's try the default command, right? This hello world. So if I click enter, it says hello world. So this is how command window works. And you can try anything. You can use it as a calculator also. As you can see, 5 plus 3 is 8, 10 by 4, right? So, so these are the things that you can do in command window, and you can also do matrices and vectors. So let's say I'm creating a vector 1, 2, 3, 4, 5, and C 1, 2, 3. See, so you can see this semicolon is mentioned for columns, and this one is mentioned as a row, right? So that's a row vector, and this is a column vector. Now you could do all of these in strips also, and editor. So this is a editor. So over here we can use if you, let's say you want to check the size, or let's say you want to add two uh, vectors, right? So let's say I have vector A, 1, 2, so let me increase it. Yeah, if you just can click Control and plus, it will increase. So I'm creating a matrix 3 by 3, and let's say I want it 2 comma 3. So I want the value which is at 2 comma 3. So now if I go here, click one, so you got to save the file. Let's say trial 2 dot m. You should always save it with m as an extension. So when I run this, you can see the answer, which is 6, right? And you can see A also 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the one of what I meant by the variables. So so grabbing A, it's just row 2, column 3, right? Gives you the value 6. And you could also play with it. You could also do a transpose, right? If you do a transpose, you get these, as you can see, answer, yeah, 147, which is 1, 4, 7, the transpose, and so on. So, so here you can do everything with scripts also. So you can also do, let's say, I'm creating another vector, b is equal to 4, 5, 6, 7, 8, 9, 10, 11, 12. And I do plus a comma b. Or you could do a plus b. Doesn't matter. Both are the same thing. So if I run, you can see it creates b vector with 4, 5, 6, 7, 8, 9. And answer is 5, 7, 9. It adds 1 plus 4 is 5, 2 plus 5, 7, 3 plus 6, 9, and so on. So this is how it works. And you can also use size. Now size is nothing but in dimension. So size of A is 3, right? 3 by 3. Now we're gonna do graphs, right? We're gonna plot graphs, and that's the fun part. So, we're gonna start from 0 to 10. Step value as 0.1. Now these are very necessary for plotting the graphs. You gotta take x values, and we're gonna take sine of each, and we're gonna plot x against y. So it's gonna be sine of x, plot of x comma y. Now if I run this, that was this thing, I should get a graph. So this is the graph that we get. It starts from 0, goes here, and goes over here at 8. Now, let's say I want to make it more professional, right? I got to label all the axes, add a title, and turn on a grid. So in order to do this, I got to add the labels. It's going to be x label, x values, y label, y values, title, my first plot, grid on. So when I run this, we can see the graph coming up. See, so this is the y values, these are x values, and this is my first plot. Right? This is the thing. And if I do y2 is equal to cos x, right, I can plot two curves at once. And I can use a legend that says which is which. Let me show you. So if I put y2 is equal to cos x, plot x comma y comma x comma y2, legend sine cos, right? So if I run this, you can see this, and you can also see the legend that says sine and cos. The red one is cos, and the blue one is sine. So this is how we use, uh, you know, Octave for plotting graphs. And we can also use functions. We can create functions and we can go to the command window and see how it is. Like let's say instead of using editor, I want to access it from command. So I could just use my graph and it will run, right? And after running, it's where we get this, right? So this is how you can run files in just the command. Or you could just go here and click this green button over here and it would still do the same thing. Now, let's say I want to create a function, right? I want to create a function. Maybe create a new script. And if you want to clear out these values, just go here and click type clear. That's it. So let's say I want to create a function. So sorry, function, let's zoom in, result is equal to add 2 x comma y, result is equal to x plus y, and so let me save this file as, let's say, func fn1.m. Should always save it with m. So let's say I go here, fn1.m. So it says there's some issues here, right? X is undefined, right? Because we didn't give the value. And functions, okay, we should always save it as, my bad, I forgot to say it earlier, is that we have to save it as a function name, as a file name, not fn.m, but as add to .m. So replace it. Yes, okay. And if I run this and 2, 2.7, 2.4, that 2 is undefined. Mhm. as you can see, the issue was the T and the T of the file name are not same. So once I've created gave both of them the same file name, all I have to do is go here, add 2, put the values you want, go 7, that's all. So this is how you create functions and you can use them in the command window. But be careful to give the same file name as a function, or else it will not work. Right? I can use it wherever you want, however you want. Now I have some control flow questions. Some questions are quite programs and how for loop and while loop works. So this is how the for loop works. For y is equal to 1.5 and display I. So it repeats a certain number of times, comes from 1 to 5, and it will print. I see to 5. And you can see over here 1, 2, 3, 4, 5. Now I can do the same thing for while, right? Let me save it. See, 1, 2, 3, 4, 5, 6. For n less than equal to 5, as long as the condition is true, while n is 5 or less, it prints and bump it up one by one. The same output, just on different style. So I say n is 6, I is 5, right? So because at the end it saves here, but then it goes to while and it does not apply. So now for the next rule, for the next part, we can try a combination of if and else statement, which I've kept over here. So for if and else statement, we are defining a variable, temperature 30. Simple if temperature greater than 25, it's hot. If not, it's cold. So if I run this, you get it's hot. It is hot, right? So this is how the control flow, basic control flow works for each of these for while, and if and else. Now let us see a mini project, right? That which is done by all of this, by if, else, and vector and printing and everything, right? It's a simple code and not that much complicated. So here we define a variable called scores 78, 92, 65, 88. We're printing average, the mean of scores, printing highest, max of scores for the for loop. I is equal to 1, 1 to length of scores. Scores I is greater than or equal to 90, right? So if the score is greater than or equal to 90, score, the value is an A, right? So if it's above 90, we put as an A, right? And and we plot them and then we give title as exam scores. Now, once I run this, I should be getting a graph, and this is the graph, right? So this is how GNU works. This is GNU Octave. You have learned variables, matrices, built-in functions, plotting and writing your own functions, and control flow. And you can also use help command, as I said earlier, in the command window to understand how it works, and it'll be really helpful for you. And this is how it shows in the command window, right? The ones that we executed right now. And hope this was helpful for you guys, and thank you. Here, A2, comma 3 will give us row 2 and column 3. Let me save the file, try it, forward that in, right? So it should give us 2 comma 3, which you have said earlier. And you can see the answer, 2 comma 3 is 6. And if I tried A is 1 comma this, right? Semicolon. You get the first whole row. The first whole row is what we'll be getting, right? 1, 2, 3. Now if I do the other way around, keeping it 2 here, 2 here, and this, guess what we'll be getting, right? Correct. We're getting 2, 5, 8, right? We just got a column. So this is how it works. So just by playing around with these, you can get it. Also, you can by putting 0 to 1, 0 to 2 to 10, you get all the values from 0 to 10, right? With a step count of 2. That's what it means. And you normally use this in functions or in scripts that we'll see later. And also, another thing that I forgot to say was that in the command window, when you type, say, y is equal to 4, right? And let's say O is equal to 4, K is equal to 3. And if I mention the semicolon, which is over here, right? It does not print it. Do you see that? It does not get printed. So, and if I type O plus K, I get answer plus 1. Okay. So this is how you can play around with command window and semicolons. Now, let us come to the main point of Octave, right? Mainly we use Octave for functions or plotting graphs. And you can use a lot of these like square root, right? You have square root 144, and that'll give you the answer. You could use, right, square for 144 as the answer. Yeah, 12, right? So you can type that, or you can also type here, not an issue, right? You can also put nums is equal to 4, 6, 10, 12, and you can call any function. You can do sum of nums. These are pre-built functions, and you don't have to create or do any of these, right? You have mean of nums, you have max of nums, you have sort of nums, right? I guess you have so many more functions which you can play around with. Let's say that you do not know any of these, one of these functions. You don't know what mean does, right? So if you want to know what mean does, you just do help. By doing this, you get it, right? So after this, let us talk about plotting graphs. And these are the fun part, right? These are places where the Octave really shines. Now, for plotting a graph, first, take a new script and mention the range. So let's say I want to take x, so ranges from 0, with the step count of 0.1 to 10, right? Y is sine of x, plotting x comma y. Now save this. Let's say plot dot n. I feel you should get a graph. Yeah, see, this is the graph that we have. Mhm.